All right, so we are continuing with the first chapter of geometry. Today is all about inductive reasoning, so make sure at the top of your notes, you're on the part that says 1.2. Their guided notes will try to go a little quicker since we did lose some time there. First definition is conjecture. Now, what? Conjecture is on the top. So it's in your notes packet actually twice under the heading 1.2 inductive reasoning. You'll see it there. It's also on the front. You can put it in either spot. You can put it in both spots. Some people prefer to have their vocab all together. Some people prefer it right where it goes. Either way, we're going to highlight it tomorrow, so your attention will be drawn back to it. It's just kind of personal preference. We put them in the front in case you're more of a list person, want them all together. If you want them right in the notes, put them there. Or do both, okay? So conjecture is a conclusion made from an experience. So usually you observe a pattern or something that's happening over and over, something you've already went through, something you've already experienced, and you sort of guess what's going to happen next, okay? All right, next one, inductive reasoning. It's the process of looking for patterns and making conjectures. All right, next one is a counterexample. It's one statement that proves a conjecture is false. So I'm going to give you conjectures that aren't true. A counterexample is very simple. You just show me one quick example or one quick statement that proves I'm wrong. Teenagers are really good at this because it's basically you're just arguing, okay? And teenagers love to argue. Okay? Questions?
Can you go back?
Yes, I can go back real quick. Hold on. All right, here's our first example. So it says, complete the following conjecture. Show 3 examples of how you came to this conclusion. So the sum of any 2 odd numbers is blank. We're going to try to finish that statement and come up with some examples to support why we came up with that. So, sum. Sum means what? Hold on. Sum means what? The total number when you add, okay? And then I'm adding 2 odd numbers. So I'm going to first come up with the examples, then I'm going to go back and make my conjecture. Someone give me an odd number. 3. Someone give me an odd number again. 9. What is 3 plus 9?
12.
Okay, great. That's one example. Give me another odd number. 7 and 5. Still gives me 12. Do what? 1 and 21 are the next 2 numbers I heard. So all of these sums are what? Even. 12, and 22 are all even numbers. Now, I always like to pause and see if I can come up with a counterexample. Can you come up with a time where this wouldn't be true? You're adding 2 odd numbers and you get something that's not even. 0 is not even or odd, so you can't use 0. Actually, I think 0 is technically considered even. It's definitely not odd. All right, can we all agree that this is correct? All right, and you need both parts. You need the 3 examples, and you need to fill in the blank too to finish the conjecture. Any questions? Here's number 2. The product of any 2 odd numbers is blank. Same idea. We're going to come up with 3 examples. We're going to try to finish the conjecture. Now, though, I'm finding the product. Product means multiply. Good. So, again, odd numbers. Someone throw out an odd.
3 and 9.
3 and 9. 3 times 9 is 27. 15. And 1 is 15. 5 and 7 is 35. So every product of 2 odds on our list is what? Also odd. Good. And then pause. See if you can catch yourself. Can you come up with something that proves that our conjecture isn't right? No, I think it's right. I just want you to pause and see if you can catch yourself. Any questions?
No, ma'am.
Show the conjecture is false by providing a counterexample. So now we're showing a counterexample. The sum of any 2 fractions is always an integer. So an integer is positive or negative whole numbers, basically. Zeros included. So 1, 2, 3, and also, 4, 5, 6, and their opposites, so the negatives. You guys know what fractions are, right? So, can you think of 2 fractions whose sum is not an integer? We're trying to prove this is wrong. So 1 over 3 added to what? 2 over 1. So if we want to add these, we can either use our calculator or we can get common denominators. So 1 over 3 plus, I'd have to multiply top and bottom by 3. I would get 6 over 3. 7 over 3. Is this an integer?
No.
It's not.
No.
Boom. This is my counterexample.
But just in case that's 2.
Okay? So all you're doing is showing one time where this statement's not true. You don't have to write me a novel. You don't have to come up with the whole list of when it's true and when it's not true. Show me one time that it's not true. The sum of 2 fractions is always an integer. Boom. No, it's not. Okay? Done. What are your questions? Here's another one. If a shape has 2 sides with the same length, then it must be a rectangle.
That's false.
It is false. You need to provide me with a counterexample.
You can draw a hexagon.
Yeah, so there's even an easier one that I was just thinking of. A triangle. You could draw an equilateral triangle.
A rectangle.
Or I guess more accurately an isosceles triangle, right? Is 2 sides are the same, that's surely not a rectangle. So you could draw counterexamples, or you could write it out like a triangle could have 2 sides that are the same length. Okay? All birds can fly.
Penguins can fly. Ostriches.
Penguins can't fly.
Penguins? Okay.
I thought penguins could even. You counted yourself as a bird. Oh, man. Chickens can't fly.
Ostriches.
There you go. Chickens can't fly. Penguins can't fly. Ostriches can't fly.
I'm gonna just put one.
Yeah, but remember, you only need one.
Ostrich.
Yes.
Actually, chickens can fly.
Tell them again.
Chickens can? Okay, don't put chickens. Apparently they can fly. I am unsure, but I will be Googling it as soon as this lesson is over. I know penguins cannot, so we can, that's a safe one. I'm sure ostriches cannot either. Do flamingos fly?
No, I'm telling you, they float. They float.
Oh yeah, they fly in The Lion King. Yes, thank you. All right, back to the lesson. Any questions? All right, shh, not quite done yet. So this says, use your calculator to explore the pattern. Write a conjecture about what you observe. So 101 times 25. What is it? 25, 25. So now we got to do 101 times 34. Is it 34, 34? Is it 49, 49?
Yes.
All right, how could we word that?
4,949.
I mean in a conjecture. Let's say any two-digit number multiplied by 101 equals any two-digit number multiplied by 101 equals, how would you describe that? That number written twice? All right, that's it for 2-1. Do you guys have any questions?
No, ma'am.
All right, I'm going to give you your homework. You got the rest of class to work on it. And just like we did today, when you come in tomorrow, I'll actually be here so I can check it for completion. We'll go over the answers. We'll move right along, okay?